Harvard astrophysicist believes there's a strong likelihood this is a craft of alien origin, and the implications, obviously, for humanity would be profound.
We are no longer alone in this universe. A mysterious object named 3I/Atlas is racing through our solar system, and it is unlike any comet or asteroid ever seen. The Hubble Space Telescope and Harvard scientists, led by Professor Avi Loeb, have revealed shocking findings. This object does not reflect sunlight. It generates its own energy from within. With an estimated power output equivalent to 10 nuclear power plants compressed into a core smaller than a football field, it defies every known rule of astrophysics. One by one, natural hypotheses have crumbled. So what exactly is this object? The terrifying truth awaits you in this video. When people first heard rumors about 3I/Atlas, it sounded like another wild internet story. But the involvement of a respected scientist changed everything. Professor Avi Loeb, former chair of Harvard's astronomy department, is known for daring to ask questions that others avoid, and this time he pointed directly at the possibility that 3I/Atlas is not a comet at all but advanced technology. His voice gave weight to claims that might have been dismissed as science fiction. And once his name appeared in headlines, the debate spread across the global scientific community. The first hard evidence came from telescopes we already trust because the Hubble Space Telescope has been capturing the glow of objects for decades. When Hubble turned its lens toward 3I/Atlas, the images revealed something that broke the rules of how comets behave. Instead of a long, sweeping tail pointing away from the sun, as every high school textbook explains, this object showed a concentrated glow facing toward the sun. It looked less like the dusty plume of ice crystals and more like a beacon shining directly forward, a light source that did not match any natural comet. This strange pattern forced scientists to consider that the glow might not come from reflection at all, but from a power source inside the object itself. If the light were just reflected sunlight, then 3I/Atlas would need to be enormous, almost 20 kilometers wide, about the size of Manhattan Island. Such giant objects are extremely rare, appearing in our solar system perhaps once in 10,000 years, and the timing alone would be a huge coincidence. But if the light came from an internal source, then the actual size of the core could be under 100 meters. Smaller than a football field, yet still producing the same glow. That means the core would need to generate around 10 gigawatts of continuous power, the same amount as 10 large nuclear power plants running at full capacity. To give a sense of scale, the bomb that destroyed Hiroshima released about 15 kilotons of explosive energy in one flash. Now imagine that level of energy being produced every few seconds inside a compact object racing through our solar system. This comparison was enough to make even veteran scientists nervous, because it meant that something small could still carry the destructive potential of a city-ending weapon. Skeptics demanded natural explanations, and Avi Loeb carefully went through them one by one. The first suggestion was a primordial black hole, a tiny relic from the early universe that could release energy through Hawking radiation. But the math showed that such an object would only emit 20 nanowatts of power, weaker than a household light bulb, far too small to explain what telescopes recorded. The second possibility was debris from a recent supernova, carrying radioactive isotopes that could shine on their own. In theory, such material could glow for a while, but in practice these fragments are almost never seen, and they cannot maintain steady brightness over years of travel. The chance of one drifting into our neighborhood by coincidence is nearly zero, so this explanation also collapsed under scrutiny. The last natural option was the standard comet model, where ice melts and dust reflects sunlight. This is the safe explanation astronomers usually prefer, but once again the data refused to fit. The glow from 3I/Atlas did not fade smoothly, and the light was concentrated at the front instead of trailing behind. If the halo were only sunlight on dust, it should look completely different, which means the normal comet theory could not stand either. Once these possibilities were ruled out, the boldest conclusion remained standing. Loeb suggested that 3I/Atlas might be generating nuclear power, operating more like a reactor than a comet. That would explain the compact size, the unusual glow, and the strange direction of the halo. It would also explain why the brightness did not match the physics of reflection, because the energy was not borrowed from the sun but produced internally. For many, this step was difficult to accept, because it moves the discussion from natural space objects to the territory of advanced technology. Yet science often works this way. Eliminate the impossible, and whatever remains must be considered, no matter how strange it sounds. If even part of Loeb's reasoning is correct, then 3I/Atlas is not just a rock drifting through space, but evidence of something built with intent. The credibility of a Harvard astrophysicist and the data from Hubble and Webb created a foundation strong enough to shake public confidence. Viewers who saw the side-by-side images of ordinary comets and this glowing object could see the difference with their own eyes. And once the numbers were explained, the scale of the problem became undeniable. For the first time, mainstream science had to admit that the safe explanations might not be enough, and that possibility opened the door to darker theories. So the question becomes clear: if 3I/Atlas is truly producing power on its own, then what kind of rules is it breaking, and what does that mean for us? The path of 3I/Atlas through our solar system is one of the clearest signs that something extraordinary is happening, because its movement does not follow the normal rules of a comet. Most comets approach the Sun on long, predictable orbits, and their paths can usually be explained by simple gravitational pull. But this object does not fit the pattern, and its journey looks more like a carefully designed route than a random trip through space. The first red flag comes from its direction of travel. 3I/Atlas moves in a retrograde orbit, meaning it is going against the flow of most planets and comets in the solar system. That alone makes it unusual, because retrograde orbits require extra energy and are rarely seen in natural objects. Even stranger, the tilt of its path is only about 5 degrees off the plane of the planets, which is almost too precise. It is as if the object chose to skim along the same flat sheet that carries Earth, Mars, and Jupiter, making its movements hard to dismiss as coincidence. Astronomers then calculated the odds of such a trajectory appearing by chance. The number they reached was around 1 in 20,000, an impossibly small probability for random motion. When you consider the vast three-dimensional space around the Sun, the idea that an interstellar object would pass so neatly along our planetary plane seems unlikely without some guiding influence. This is why many observers suspect that the orbit itself may be part of the evidence for design. The route also raises new questions because of the way it interacts with key worlds. Instead of passing through the outer solar system unnoticed, 3I/Atlas swept past Earth, then curved near Mars, and finally moved toward Jupiter. These three worlds are not just random destinations, they are exactly the planets most closely tied to human exploration. The idea that the object would just happen to align with these worlds is difficult to accept. Some researchers have compared this to reconnaissance, as if the object were mapping or surveying our system in a deliberate way. The flybys look more like a planned survey route than the messy wanderings of an icy rock. And when you add the glowing nuclear core to the picture, the path begins to look less like chance and more like strategy. If this is true, then 3I/Atlas is not only powered but also guided with intent. Skeptics argue that gravitational nudges from the Sun and planets could explain the unusual path, but this answer feels incomplete. Gravitational assists are common in spacecraft navigation, yet for a natural comet, the chance of hitting this sequence of encounters is slim. The precision of the alignments continues to suggest that something more than luck is at work. Even if the orbit began naturally, the exact tuning of its flybys hints that some form of control may be adjusting the course. If the orbit is guided, then 3I/Atlas may be more than just an engine or a reactor. It may be a probe with a mission. Its path across the solar system could be a demonstration of power, a quiet reminder that it can choose where to go and what to observe. For humanity, the realization that we might be under observation changes the mystery into something far more personal. So the question becomes impossible to avoid. Is this path a freak accident of gravity, or is it the signature of an intelligence steering a machine across our skies? If earlier evidence made 3I/Atlas seem unusual, then the details of its internal activity push it into the realm of the impossible. Because every observation points to violations of physical laws that should never be broken. The gamma radiation detected around the object is not random like the decay of natural elements, but instead follows precise mathematical sequences. Each pulse looks more like a coded signal than a burst of chaotic energy, suggesting that a control system is adjusting the reaction with accuracy that no natural process could achieve. Controlled fusion is one of the hardest challenges in modern science, since even the most advanced laboratories struggle to keep plasma stable for more than a few seconds. Yet this object appears to sustain fusion constantly while moving through deep space, where solar winds, cosmic rays, and gravitational forces should disrupt every attempt at stability. The problem becomes greater when we examine its fuel supply. Spectral data shows hydrogen levels remain steady instead of dropping, which means the reaction is not consuming fuel the way fusion normally does. Helium, which should be accumulating as a byproduct, is absent, leaving researchers with only implausible explanations. Some suggest it may be pulling energy from the quantum vacuum, while others imagine processes that recycle fusion waste back into usable fuel. Either way, it appears to cheat the laws of thermodynamics, creating a source of energy that should not exist in nature. The surface adds another layer of mystery. In a normal reactor, high-energy neutrons would tear apart any protective shell within months, no matter how strong the material is. This is why fusion power on Earth remains out of reach. The walls of the chamber cannot survive the constant bombardment. But the outer layer of 3I/Atlas shows no trace of neutron damage, no cracks, and no decay, almost as if the radiation is either absorbed, redirected, or turned into additional energy. Such resilience would require matter with properties far beyond anything found on the periodic table, perhaps a form of self-healing material that science has not even imagined. The mystery deepens when we look at its movement. All spacecraft we know obey Newton's third law. Thrust comes from pushing mass one way, so the ship moves the other. 3I/Atlas shifts direction without leaving behind any exhaust, no plume, and no sign of expelled matter. The only possible explanation is that it manipulates gravity itself, bending spacetime to move without traditional propulsion. This would make it the first real example of reactionless drive, something that could allow travel between stars without carrying massive amounts of fuel. Even more chilling is the question of control. The gamma-ray patterns do not just mirror the energy needs of the craft, they seem to anticipate them. When its path changes, the nuclear output rises exactly in advance, almost as if it knows what is coming. The only way to explain this is to assume the presence of an intelligence beyond our normal idea of computers. Scientists describe it as a quantum mind, capable of experiencing multiple futures at once and choosing the best outcome before events unfold. Such a system would not react to the environment, but would stay ahead of it, giving the impression of foresight. If this is true, then 3I/Atlas is not only a machine, but also a form of consciousness, one that exists outside the flow of time as we know it. It may not think in human terms, yet its ability to adapt and respond proves that it is guided by intent rather than chance. For humanity, the discovery that intelligence can be built on principles beyond biology is almost as frightening as the object itself. It means that in the universe, thought and awareness may take shapes we are unable to recognize until they stand right in front of us. So the evidence builds toward a single terrifying idea. This is not just a comet, not just a rock glowing with strange energy, but a machine run by physics-breaking technology and perhaps by a consciousness far beyond our own. And that leads to the next question. If such impossible abilities are real, then where did this machine come from, and what kind of civilization has the power to create it? If the strange light and impossible physics of 3I/Atlas are shocking, then the composition of its material is even more unsettling, because the isotopes detected do not fit the fingerprints of any natural star. When scientists study the birth of elements, they can usually trace where they came from. Heavy elements in our solar system carry unique patterns that show whether they were forged in supernova explosions, white dwarf outbursts, or neutron star collisions. But the isotope ratios inside 3I/Atlas fail to match any known process, which means the fuel at its core is not natural at all. This detail suggests that the material has been refined with a precision that only industry could provide. Instead of random mixtures of nuclear ash, the core looks like it has been purified and rearranged, the way we refine uranium on Earth, but at a scale far beyond human reach. It is as if someone took the raw output of dying stars, filtered it, and combined it into a perfect recipe for endless fusion. Such work would not be possible with a single factory or even a single world. It would demand infrastructure spread across multiple systems, harvesting matter from stellar furnaces and then shipping it across space to be processed. This detail suggests industrial refinement at a galactic scale, harvesting and processing stellar matter. Instead of trucks and refineries, picture ships the size of moons extracting stellar debris, carrying it across light years and feeding it into plants that reshape atoms themselves. That is the kind of technology required to explain the nuclear fingerprints of 3I/Atlas. The more scientists examined the trace elements, the stranger it became. Certain exotic materials appeared in amounts that cannot exist naturally in our region of the galaxy. Some isotopes are so unstable they should not survive the trip through interstellar space. Yet here they are, sitting inside this object as if freshly manufactured. This means the civilization behind it must not only collect matter but also stabilize it, perhaps using methods that control decay at the atomic level. Such control would make them masters of matter itself, turning the universe into a workshop rather than a wilderness. The conclusion is hard to avoid. 3I/Atlas is not simply powered by advanced fusion. It is built from ingredients that nature cannot provide on its own. It represents industrial power at a scale humans can barely imagine, a civilization treating galaxies as their supply chain. For us, it is like finding a machine that runs not on gasoline but on the fire of stars, assembled with parts pulled from neutron collisions and supernova remains. It is both terrifying and humbling, because it shows that intelligence can rise to a point where even cosmic events become raw material. If such a civilization exists, then its timeline must stretch back millions of years. They would have had the patience to build across eras longer than human history itself. They might view our struggles with energy as primitive, the way we look at cavemen trying to spark fire with stone. And if this is only one small craft, then it is not the peak of their power, but just a tool, perhaps as common to them as a car is to us. This realization changes the meaning of 3I/Atlas. It is no longer simply an interstellar visitor, it is a messenger showing us what lies beyond the horizon of our science. It proves that matter can be harvested on a galactic scale, that fusion can be controlled without waste, and that civilizations may grow so vast that stars become resources rather than mysteries. The real fear is not only that they exist, but that we may one day cross paths with their greater machines, the ones designed not for travel, but for defense or war. And that leads us to the next question. If 3I/Atlas is only a scout powered by stellar fuel, then what would their weapons look like? And how would humanity survive if such power were ever turned against us? Not every scientist accepts the idea that 3I/Atlas is artificial, because alternative explanations still exist, and these voices remind us that science must balance bold claims with caution. One of the most common counter-arguments focuses on the scattering of light by dust particles. When sunlight passes through fine grains, the glow can appear brighter in unusual directions, sometimes even facing the sun instead of trailing away. This effect, called forward scattering, could account for the strange halo without requiring an internal reactor. Another possibility involves the viewing angle. Telescopes on Earth and in orbit capture light from great distances, and sometimes geometry plays tricks on what we see. If the angle of observation happens to align with the thin dust cloud around the object, then the glow may appear concentrated or uneven. This could explain the cliff-like drop in brightness, making the effect an artifact of perspective rather than evidence of advanced power. Such errors have happened before in astronomy, where later observations corrected what looked like impossible behavior. Scientists also warn about the limits of current data. Most measurements of 3I/Atlas come from brief windows when telescopes could observe it, and these snapshots may not reveal the full picture. The brightness could vary with distance in ways we do not yet understand. Or the dust may respond to solar radiation pressure differently than expected. Until continuous tracking is achieved, the most extreme interpretations may simply rest on incomplete evidence. These counter-arguments do not erase the mystery, but they keep it grounded. They remind us that natural explanations, even rare ones, should be tested fully before we leap to the idea of alien machines. This is not to dismiss Avi Loeb's theory, but to show that science grows stronger when it entertains multiple options. If dust scattering or geometric effects can explain the glow, then the story shifts from an alien probe to a lesson about how much we still need to learn about comets. In that sense, the real value of 3i/Atlas may not be whether it is artificial or natural, but how it pushes us to think. It brings together fear and curiosity, making us admit both our vulnerability and our potential. But even as we consider these cautious explanations, one question lingers. What if the truth is more extraordinary than either side imagines? And what if this object is not only a clue about the cosmos, but a warning about the next stage of human history? The journey of 3i/Atlas through our solar system presents a paradigm-shifting mystery. Its anomalous characteristics, glowing equivalent to 10 nuclear reactors, a precise and improbably aligned retrograde orbit, skirting key planets, and isotope ratios suggesting artificially refined stellar material, defy all conventional natural explanations. One by one, hypotheses from primordial black holes to radioactive supernova debris have crumbled under scrutiny. The most compelling, albeit extraordinary conclusion is that we are witnessing a piece of advanced technology, a probe powered by controlled fusion, potentially guided by a form of non-biological consciousness and constructed from resources harvested on a galactic scale. While healthy scientific skepticism remains regarding light-scattering effects and observational angles, the sheer weight of evidence challenges our understanding of physics and our place in the universe. Rather than inciting fear, this revelation should ignite a profound sense of wonder and purpose. It serves as the most powerful catalyst for human exploration, scientific collaboration, and technological aspiration we have ever encountered, proving that the next great chapter of discovery lies not just on other planets, but in reaching for the stars themselves.